evening, ladies and gentlemen. I present to you the Internet Study Mate Problem of the Day from Accra Girls SHS2. I am Lisa Ohinikoba.
I am Mariano Khan.
And I'm Deborah Sachi.
We are all in Form 2. The ISM problem of the day is 3 factors that affect the rate of photosynthesis. You might be wondering, what is photosynthesis? Photosynthesis, in my opinion, is a biological process whereby green plants manufacture their own food, synthesizing organic substance from carbon dioxide and water, utilizing the energy absorbed from the sun by chlorophyll. The 3 factors that affect the rate of photosynthesis. The term rate involves time, so the rate of photosynthesis is how fast photosynthesis takes place. Many factors affect photosynthesis, but the main ones are known as the limiting factors, and these factors are light intensity, carbon dioxide, and temperature. They are limiting because at a point in time, if one of these factors is in low supply, then the rate of photosynthesis will be very slow. I begin with light intensity. The rate of light-dependent reactions and the rate of photosynthesis is directly proportional to the light intensity. Therefore, as the light intensity increases, the rate of photosynthesis increases linearly from A to B from the graph shown below. So as the light intensity increases, the rate of photosynthesis also increases, that is from A to B. However, when the light intensity increases further, it is limited by other factors such as temperature and carbon dioxide. At this point, the rate of photosynthesis becomes constant from B to C on the graph. Here, a rise, so like from B to C on the graph, photosynthesis is constant. So here, a rise in light intensity has no effect on photosynthesis. Has no effect on photosynthesis. The light at extremely high intensity can damage the chloroplasts in the leaves. And then move on to temperature. The higher the temperature, then typically the greater the rate of photosynthesis because it is a chemical reaction. However, for photosynthesis above 40 degrees Celsius, the rate slows down. This is because the enzymes involved in a chemical reaction of photosynthesis are temperature sensitive and are destroyed at higher temperature. That is, they are denatured. This is shown in the diagram below. So as the temperature increases, the rate of photosynthesis also increases. That is, at optimum temperature, the enzyme is most effective. So as the temperature increases further, the enzyme becomes denatured and the rate of photosynthesis falls since they are no longer effective. I then move on to carbon dioxide. Carbon dioxide, utilized by a land plant, is absorbed by the leaves from the atmosphere. If a plant is deprived of carbon dioxide, no photosynthesis will occur. This is because carbon dioxide is used to make sugar, specifically starch, in the photosynthesis reaction. It is normally present in the atmosphere at very low concentration, that is about 0.04%. Increasing carbon dioxide concentration causes a rapid rise in the rate of photosynthesis, which eventually plateaus when the maximum rate of fixation is reached. This is illustrated in the diagram below. So as the carbon dioxide concentration is increased, the rate of photosynthesis automatically increases and then becomes constant from this point only. Now we move on to the second question, which will be presented by Deborah Sachi. Thank you very much.
The second question emphasizes on an experiment to illustrate that light intensity is actually needed for photosynthesis. 2 plants are used for this experiment, plant A and plant B. Plant A is placed beside the window in a room, and plant B is placed in the open field. Plant B has a higher rate of photosynthesis than plant A, because it is placed on the open field and it is exposed to light from all directions, and therefore photosynthesis takes place in the whole plant and there's a high rate of photosynthesis. Now, this is because the greater the light intensity, the greater the number of photons striking chlorophyll molecules, therefore an increase in the rate of photosynthesis. Plant A, however, placed in the room by the window, will receive light from a unilateral source, which is it receives light from only one direction, and therefore photosynthesis is not effective. Hence, only some part of it will receive light. Due to this, photosynthesis is at a lower rate as compared to plant B. Our third question is actually a statement which says that the higher the rate of the light intensity, the higher the rate of photosynthesis. Now, the higher the rate of temperature, the higher the rate of photosynthesis. This statement is not always true. It is true that at low temperatures, the enzymes of photosynthesis reactions do not have enough energy to meet many substrate molecules. So therefore, the reaction is slowed. However, at optimum temperature, which is 40 degrees Celsius, the enzyme is most efficient, as mentioned earlier from the bell valve, under the temperature being a factor of photosynthesis. However, at extremely high temperatures, that is, temperatures exceeding the optimum temperature of 40 degrees Celsius, the structure of the enzyme is broken down. That is, it is denatured and cannot be used again. This explains why the statement is not always true, even though at high temperatures, the rate of photosynthesis increases. So, from the beginning to the end, we see the factors that affect the rate of photosynthesis: carbon dioxide, temperature, and light intensity. And we also see how light intensity affects the rate of photosynthesis, and an experiment illustrates it. It also shows that the higher the rate of temperature, the photosynthesis also increases, but at extremely high temperatures, that is beyond 40 degrees Celsius, the enzymes become denatured and therefore photosynthesis decreases. Thank you very much.
Ladies and gentlemen, I hope we all enjoying this salient points given from the questions asked from above. We hope it is much precise and concise. Thank you very much.